the last series, we designed a fault tolerant and scalable job queue. We'll continue the same theme of fault tolerance and scalability, and we're going to discuss about circuit breaker pattern. Now, this pattern is quite useful when a microservices based architecture is used. Why is that the case? We'll discuss later. Now, as is the case in this entire video series of discussing software design using pen and paper, we are going to design and implement a circuit breaker library from grounds up. So let's talk about what is a circuit breaker. Now, the idea of circuit breaker comes from electrical circuits. So it's basically essentially a switch that is designed to it's designed to protect the circuit from surge of electricity. Essentially its basic operation is to interrupt the current flow sorry about that current flow after, this is important, right, after a fault is detected. After a fault is detected. There's a third important point about a circuit breaker library, which is that it can be reset. Now, unlike a fuse, which we all know blows up if there is a fault or a surge, a circuit breaker can be reset to resume normal operation. Now, this is quite an important point. So this is what a circuit breaker is from an electrical circuit background. Now let's see how this applies to software. The circuit breaker library was popularized in the book Release It by Michael Nygaard. It's a very good book. I would highly recommend it. It has many more patterns described in it, and it goes in depth about designing production ready software. So let's see how this maps to software now. Now, from a software point of view, what we want to do is we do need a switch which can protect our system to an extent, protect the system from faults. Now, what we also wanted to do is to interrupt normal flow when a fault is detected. Interrupt normal flow when a fault is detected. Fault is detected. And also what we wanted to do is it has to reset at some point in time to resume normal operation, so if at some point if it realizes that the normal operation is okay, we wanted to reset to continue using the normal operation. Now let's consider an example about how this principles or how this concept maps out. So let's consider that we are running a service similar to Netflix. So let's assume that we okay. So this is the browser, and it communicates with the server which has an aggregator service running on it. Now this aggregator service talks to a recommendation service which essentially provides personalized recommendations to users. Which video titles they might like. Very very common to Netflix. Also it talks to, let's say, titles or metadata service which provides information about the video. Then maybe it also talks to the trends service which basically shows okay what's currently trending. So let's assume that something is wrong with recovery service. Essentially it's experiencing some faults, and the aggregator service keeps waiting for the recommendation service to respond. There are two issues with this. Number one issue is that we keep sending requests to recommendation service. We are essentially overloading recommendation service when it's experiencing faults. We are making the problem worse. We are making the problem worse. The number one problem. The second problem is now that one of the requests from aggregator service has faced this problem, we don't do anything about it. In fact, we all our requests to this keep getting queued here because we are waiting for recommendation service to respond. And then overall what we have done is we have reduced the quality of service to all our users. So the quality of service has reduced to all our users. In fact, all our users are experiencing faults, and they can't watch the videos that they want to watch. So this is a big issue, and especially for a company like Netflix, it can lose a lot of money if something like this happens. So instead, let's assume that the aggregator service has an alternate source of recommendation. Now this alternate source is very simple. Let's say it's a static list of recommendation. Static list of recommendations. This is not personalized. It's just some static list which is compiled by somebody at Netflix. So This is, of course, this is not as good as the personalized recommendations, but the important point is it is something. All right, it is something which we can still use. So instead of waiting for the recommendation service to respond, now what the aggregator start service could do is to the aggregator service instead of waiting for the recommendation service could use this static list. Now, in order to do this, the aggregator service has to do certain things. One, it has to fail fast. Now, what we mean by this is, let's say a request goes to aggregator to the recommendation service, and the aggregator service has to put a strict timeout on it. It cannot just keep on waiting for the recommendation service to come back. It has to time out early. So fail fast essentially means we time out early or we bail out early. The second thing, this is probably the most important thing, is the moment the aggregator service realizes that recommendation service is experiencing faults, it has to start using the static list for a while. Use static list for a while. Now this is important. This for a while is important. Now after some time, at random, or after certain number of requests are passed or certain time has passed, it has to probe. It has to probe the recommendation service to see if it has resumed normal operation, if it's no longer experiencing any fault. If that is the case, then eh, we want to we want the aggregator service to start using recommendation service, to resume using a recommendation service. Now, as you can realize, this pattern can be used across services. So this pattern is quite simple. In fact, this has these three essential steps. One is, as we discussed, fail fast. Two is use an alternate or secondary source of information. The third is probe if the primary source at certain point or after certain number of requests are passed or randomly, if we have to probe if the primary is up, and if the primary is up, then we have to reset to using the primary. Now let's see why this pattern is so useful in a microservices based architecture. Now, a microservices architecture generally is a DAG, or what we call as directed acyclic graph of service invocations. So it would look something like this, right? You have a number of microservices. This service talks to another service, and this service talks to another service, or a couple of services, and this service talks to probably another couple of services. This relies on this, let's say, and also this relies on another service. This also, let's say, relies on this service, another service, so on. So it's essentially a DAG, or a directed acyclic graph of service invocations. Now let's assume that this service, let's call it as A, starts to fault. Now what ends up happening is it ends up holding the request at this service, which ends up holding the request at this service, which ends up holding the request at this service, as well as this service. Now soon we can see, as an entire system, it's starting to experience faults, and it's essentially delaying response to the user. So the system essentially freezes up and it degrades very quickly. So we want to avoid this situation. So if we use the circuit breaker pattern, uh, what would happen is if this service will have an alternate, it will fail fast and then respond to this, and then it starts responding to all of this. The important point is, for a while we use the secondary source of information. Now source, uh, the secondary source may not be as good, but the important point, as we discussed earlier, it is something, and what it allows is it allows us to avoid this situation of freezing up, allows us to avoid this, and it allows us to continue to serve our users, although may not be as good as what primary would have let us do it. So for example, personalized recommendations are always good than a static list, but we still allow the users to watch the videos in the case of example of Netflix. So there's another small point that I would like to mention is that Netflix, in fact, uses this pattern quite extensively. They, in fact, designed and implement. They've released an open source library called Districts, um, which is essentially a circuit breaker library. They used it internally, and now they have open sourced it. So this completes part one of the video, and this is just an introduction. What I have done is I have designed and implemented a simple and more importantly an extensible circuit breaker library called Nischita. It's an open source library. It's there on my GitHub profile. I'll provide the link in the description. Now Nischita in Sanskrit, it means decision or to decide. So I think it's an appropriate name for a circuit breaker library which has to decide whether it has to use primary source or secondary source of information. We'll in the upcoming videos we'll go into the details of how to design this simple and extensible circuit breaker library. We'll go through the choices we have made and the implementation details. Another point to note is this is a library for Node.js, a circuit breaker library for Node.js and JavaScript. So thank you for watching. I'll upload the rest of the parts quite soon. Thank you.